Hi you guys. What we're going to do today is we are going to figure out how to determine if two triangles are similar. So the first video you watched, I told you they were similar and we multiplied the scale factor to find the new triangle. What's going to happen today is I'm going to give you two triangles and we're going to work backwards and verify that they have the same scale factor to show that they are indeed similar. So what's going to happen is you're going to start off with two triangles. So here I'm going to start with my big triangle A, B, C, and a similar triangle D, E, F. As of right now, I don't know that they're similar. I could see that they're the same shape. They're different sizes, but I don't know that they had the same scale factor. What you're going to notice is you're going to have three sides of your triangle. Each side is going to have a measurement. All right? So on this problem, I'm going to make this measurement 12, this measurement 16, and then this measurement 20. So what I like to start with you guys is identifying your small side, your medium side, and your large side. That's going to be important to make sure you match it with the corresponding part in the second triangle. So I'm going to highlight my small side in green, my medium side in orange, and my large side in blue. All right, so what I'm going to do now is I'm going to write my new triangle's measurement. So this new triangle went from 12 to 3. This new triangle went from 16 to 4. And this new triangle went from 20 to 5. On this second triangle, you're going to do the same thing. You're going to identify your small, medium, and large side. So you match them up with the corresponding part in your first triangle. So here's my small, here's my medium, here's my large side. What we're going to do is we're going to determine that they are similar triangles by finding the scale factor. If all three sides have the same scale factor, we can conclude they're similar. So finding the scale factor, we're going to put our new triangle over the old triangle. So this is our original, the old, and here's my new triangle, the smaller one. What you're going to get is a ratio. The ratio is going to give us the scale factor when we simplify it down of what we did to get from this green to that green. All right? So what we're going to do is we're going to look at all three sides, your small, your medium, your large side. My small side, the new small side, 3, over my original small side, 12. You can divide this down. 3 over 12 is the same thing as 3 divided by 12. 3 divided by 12 is 0.25, or this simplifies to 1/4. So what we found is to get from this side to this side, the 12 to the 3, I multiplied by 1/4, or I multiplied by 0.25. It's 1/4 of the size. So what we want to verify is that we get the same scale factor, 1/4 or 0.25 in the other triangles. All right, so my medium, my orange, my new medium is 4. My original medium is 16. That's really 4 divided by 16. That simplifies, to 1/4. 4 divided by 16 also is 0.25. So far we are good. We have that 2 of the 3 sides are similar because they have the same scale factor. Same thing with our large, or the longest side. My longest side are the blue sides. The new one is 5. The original is 20. 5 divided by 20 is 0.25. 5 over 20 is 1/4 as well. So since all 3 sides have the same scale factor, we have a scale factor. I don't care if you write it as 1/4 or 0.25. We can conclude triangle ABC is similar to triangle DEF. So when we verify the scale factor is the same, then we can conclude congruent triangles. All right, let's say we have this example right here. So on this problem, what you're going to see is you might not have all 3 sides to check. We're going to use side angle side similarity to check here. So I have my angle, that's the same in both. And I'm going to have that this is 8, this is 10, this is 16, this is 20. So instead of identifying all 3 sides, what we're going to identify are 2 sides. I have the smaller side 8 and the smaller side 16 in each triangle. 8 is smaller than 10, 16 is smaller than 20. And then I have a longer side 10 and a longer side 20. So what I'm going to verify are these 2 triangles are similar by side angle side, where these were similar by side side side, by checking the scale factor on the 2 sides in the triangle. So we already have that the angle is congruent. We're going to check the scale factor is the same on the small side and on the large side. So what we do is we put the new over the original. So here you're going to see my new triangle's my bigger one. The original is my smaller one. So my new smaller side is 16. 16 corresponds to 8. 16 divided by 8 is 2. So what I get in this problem, my scale factor is 2. I'm going to check my blue side, my larger side. My longer side on the second triangle is 20. The longer side on my smaller triangle is 10. 20 divided by 10 is 2. And I get that my scale factor is 2 on both. So since they have a congruent angle and the same scale factor for the sides of times 2, we can conclude, I didn't name this triangle, BDE. The first triangle, BDE, is similar to the second triangle, GHI. And we're using side angle side. So what you're going to see on this last problem right here is you might get a problem where your triangles don't match up. So say I have this triangle 8, 10, 12, and over here I have this triangle 4, 5, 7. So some of you would be able to identify right from the get-go. I'll call this D, E, F, GHI. For each triangle, I have a small side, so 8's the smallest side. My medium on this triangle is 10. I'm gonna make medium 10 blue, and my large side is 12. So small, medium, large. When I match it up over here, small is 4, medium is 5, large is 7. So what you're going to see when we look to check the scale factor, when we're looking at the 3 sides, my new small to my original small is 4/8. 4 divided by 8 is 0.5, or that reduces to 1/2. So the scale factor from the green to the green is 1/2. When I check the medium 10 to 5, my new scale factor is 5 over the original 10. 5 divided by 10 is 0.5, and that is 1/2. The problem comes when we compare our longest side, the orange. The orange of the new triangle is 7 divided by the new orange 12, or the original orange 12. 7 divided by 12 doesn't give you 0.5. It gives you 0.5833. What you're going to see is the scale factor is not the same. So it has to be the same for all the sides. So what we can conclude, these are not congruent, or not similar. These aren't similar triangles. The only way that they're similar is if their corresponding sides reduce down to the same scale factor. All right, we're going to continue similar theorems at the end of the week, but we just did how to create similar triangles by multiplying by the scale factor. Here we determined if they were similar by setting them up and finding the scale factor.